Okay, so greetings, welcome to today's class. So a quick recap of what we were discussing. In the last class we completed the discussion on various engine performance parameters, and we also looked at the concept of mean effective pressure and how to get an expression for the indicated mean effective pressure for the as standard Otto cycle, right. So that is where we stopped, and we identified that the mean effective pressure, which is indicative of the average pressure in the combustion chamber that will get me a particular power output, is of course dependent on the initial pressure, right, at the start of cycle, right. So as we can observe from this expression, IMEP depends on P1. P1 is the pressure inside the combustion chamber at the start of the combustion, at the start of the cycle, right. So if I want to increase the mean effective pressure, one way of doing it is to increase the value of P1. So if I increase the value of P1, obviously the value of mean effective pressure will increase, and so would the power output from the engine. So the question becomes, how do we increase the value of P1, and that is where the concept of supercharging comes into play. Okay. So recall that for a 4-stroke engine, the brake power output, we can write it as some constant multiplied by BMEP multiplied by the displacement volume multiplied by n by 2. Okay. So where n is the number of revolutions of the crankshaft per unit time, right. So the reason why we are doing n by 2 is that there is one cycle for every 2 revolutions of the crankshaft. Okay. That is why we write n by 2 explicitly, right. Okay. So we can immediately observe that we can increase the brake power through two choices. One is to increase the BMEP, okay. Another is to increase the value of N. Okay. So these are the two alternatives available to us, right, to increase the brake power output. Okay. So we can observe that increasing BMEP would essentially involve, okay, increasing the pressure at which air or the air fuel mixture is introduced into the combustion chamber. So if we can increase the intake pressure, that is the pressure at which the air or the air fuel mixture is introduced into the combustion chamber, we could increase BMEP as we just discussed, right. Yeah. So this process is called as supercharging, and a device used to achieve the same is called as a supercharger. So supercharging is a process of making sure that the air or air fuel mixture is introduced into the combustion chamber at a pressure higher than atmospheric. So those engines are what are called supercharged engines, right, and a device which does this function is what is called as a supercharger. Okay. So, let us look at what benefits we get out of supercharging. So, the benefits are the following. Okay. So, if I increase the pressure at which air is taken into the cylinder, the density of air would obviously increase, right. I am pressurizing air, the density of air increases. So, if the density of air increases, we can immediately observe that for the same volume I would have a increased mass of air, right. So, if I take the same cylinder for the same displacement volume, if my density is bigger, the mass will be density multiplied by volume, right, that is going to be higher. If the amount of air which I have taken into the cylinder is more, then the volumetric efficiency would increase, right. So, obviously that is one benefit of supercharging. Okay. So, the first benefit is, there are multiple benefits, we will go one by one. So, the density of the intake air increases. So, this implies that the mass of air taken into the cylinder also increases. This implies that the volumetric efficiency increases, which is beneficial for us. Okay, so that is one benefit of supercharging. So, the volumetric efficiency of the engine would increase. And as we have just discussed, supercharging also increases the mean effective pressure. Okay. If the mean effective pressure increases, that means that the power output increases, okay, which implies that the thermal efficiency also becomes better. Okay, the thermal efficiency of the engine increases. Okay, so that is another advantage of supercharging. And we can immediately observe that by supercharging we get more torque / power output is obtained for the same displacement volume. So, if you have the same cylinder volume, right, we get more power output or torque output. And please remember, for the same cylinder size, the specific power as we defined in the previous class is the power output per unit area, right. So, specific power output also increases with supercharging. Okay. So, we can alternatively interpret it as, right. So, if I want a fixed value of power output or torque output, I can work with a reduced displacement volume, right. So, that is an alternative viewpoint. If you have the same engine, the same displacement volume, the power output increases. If you want the same power output with supercharging, I can work with a smaller displacement volume. Okay. So, that is another advantage of supercharging. So, in other words, the specific power output increases and we get more power output for the same engine size, right. So, those are all benefits. Of course, nothing comes free. There are what to say, challenges in supercharging the engine also, right, because if we increase the operating pressures, we need to ensure that the engine structure, the cylinder block, right, and other components have to be strengthened such that they can withstand the higher mechanical loads, right, that come about due to increased pressures. And obviously the cost of the engine increases because supercharging involves the introduction of more components. So, the cost and complexity of the engine increase with supercharging. Okay, so those are the what to say essentially requirements, right, that come about with supercharging. Okay, that is, we need to ensure that the mechanical loads are accounted for and withstood by the engine components and the structures, and we have to essentially introduce more components, and that will increase the cost and complexity of the engine. Okay. So, please note that more mechanical loads on the engine, okay, and cost and complexity increase. So, we can say these are the cons of supercharging, right. So, and of course, by the end of today's class we will also discuss one more phenomena which is going to what to say influence which engines are supercharged and under what conditions and so on, right. Okay. So, if you consider a supercharger per se, broadly, please remember supercharger is the device that achieves this task of supercharging. So, typically they are classified into what are called as mechanically driven superchargers, okay, and what are called as turbochargers. So, we would have encountered this term turbocharger in practice, right, more frequently. So, we will see what it means, right. So, what is a mechanically driven supercharger? A mechanically driven supercharger is one where the supercharger is driven by the engine crankshaft. So, please note that like if I have to compress the intake air and increase its pressure, I need to impart some energy to it, right. So, the energy should come from some place. Now, the question becomes like if I use the energy which is available at the crankshaft output to power my supercharger, that supercharger is what is called as a mechanically driven supercharger. Please note that when we discuss the energy balance in an engine, if you recall the term C, where we told that look, that is a component which is used for overcoming friction and also to drive other devices and so on, right, in the engine. So, if we use a mechanically driven supercharger, the crankshaft also would be driving this device, right. So, energy is taken out from the engine output, right, for this purpose. So, obviously, the what to say, the limitation of this supercharger is that we are going to expend energy, right, to pressurize the air. So, the useful energy which is available at the engine crankshaft output is provided as input to the supercharger to pressurize the air which is taken into the engine. So, then the question is what is the benefit that we will get, right. So, that becomes an important question for a mechanically driven supercharger. So, in that regard, turbochargers have become very advantageous today. What is a turbocharger? A turbocharger is a device that uses the energy that is available with the engine exhaust gases to pressurize the air which is taken into the cylinder. So, a turbocharger is a device which is driven by a gas turbine, which in turn is driven by the exhaust gases. From the engine. So, please note that like when we discussed even like indicated power, right, or indicated energy, there was one term B, right, which included the loss to coolants, right, the energy loss due to engine exhaust, right, and so on. Okay. So, we can immediately observe that the engine exhaust is also like possessing a significant amount of energy, right. Now, the question is that can we tap into that energy and pressurize my intake air? That is what a turbocharger does. So, a turbocharger essentially uses this energy which is available in the engine exhaust to drive the gas turbine, which in turn pressurizes the intake air. So, let us look at how a turbocharger works, okay, and then we will discuss some aspects of it. Okay. So, this is just a broad schematic to explain how a turbocharger functions. Okay. So, we can see that this is the intake valve, okay, and this is the exhaust valve, right. So, this is a schematic where we can observe that the exhaust gases travel to the exhaust manifold and that from there into this device which is called as the turbocharger, right. Turbocharger takes in atmospheric air and the energy which is available from the exhaust gases is transferred to the air taken from the atmosphere. That air is pressurized and the pressurized air is then fed to the engine intake manifold, right, for distribution into the cylinders if we have a multi-cylinder engine. Okay. Now, we can immediately observe that here I am not tapping into the crankshaft, right, for pressurizing my intake air. So, we are only using the energy from the exhaust gases to pressurize the air taken into the cylinder. So, that is a advantage, that is a very big advantage for us. Okay. So, we can immediately observe that once I pressurize the air in this turbocharger, its pressure increases, but also its temperature increases, right. Once we compress air, like we look at a reservoir of compressed air, like we will see that if you pressurize air and store it in the reservoir, the air gets pressurized, but its temperature also increases. So, if I supply that air at high pressure and temperature directly to the engine, what will happen? See, with pressurized air the density will increase, but with the simultaneous increase in temperature the increase in density will not be significant, right. There will be a trade off between the increase in density due to pressure and decrease in density with increase in temperature. So, the increase in density may not be to the level that we would want, and if the increase in density is not significant, what is going to be affected? Volumetric efficiency, because I want my also like intake air to be sufficiently dense, so that the mass of air taken in for the same displacement volume is more, that would increase the volumetric efficiency of the engine, correct. So, that is why we have what is called as an aftercooler or intercooler. So, an intercooler, these are names given to this unit which is placed at the outlet of the turbocharger, is used to decrease the temperature of air coming out of the turbocharger. okay. So that the density of air which is supplied to the intake system is more, and that increases the volumetric efficiency of the engine also. Okay. So, this is how a typical turbocharger works. So, it uses the energy from the exhaust gases and essentially pressurizes the atmospheric air, and a turbocharger with intercooler is a system where you use an aftercooler or an intercooler to reduce the temperature of that pressurized air and supply it to the intake valve. Okay. So, this is the turbocharger.